Hi, this is Mr. Mack. This is a concept video on multiplying and dividing rational expressions. Now, the idea behind multiplying and dividing rational expressions actually comes from the way we operate with fractions. If, for example, we have the fraction 8/15 and we're multiplying that by the fraction 35/12, then the way you should have been taught to do this is to make sure that both of the fractions are reduced, and if there is a factor in a numerator in one of the fractions and the same factor in the denominator of another fraction, those factors can be cross-canceled. Now, in this case, for example, if you look at this, there's a factor of 4 in 8. 8 is really 4 times 2. And there's a factor of 4 in 12. 12 is really 4 times 3. So, okay, now let's continue on here. 15 is really 3 times 5. And then 35 is 5 times 7. Now, if there's a factor in the denominator and a factor in the numerator of this multiplication problem, they can be cross-canceled. 4 cancels with 4. 3, oh, no, not the 3. 5, oops, let's ungroup that. The 5 cancels with the 5. Now, those are all the factors in the denominator and numerator that are alike. So then we multiply across. 2 times 7 is 14, and 3 times 3 is 9. So we get 14/9 for our answer on that one. Now, if you have a division problem, for example, let's say you have 2/9 divided by 1/6. One of the things that you were taught is when you were dividing fractions, you flip the second fraction and multiply. So this becomes 2/9 times, or times 6/1. Now, there's a factor of 3 in the 9, leaving 3, a factor of 3 in the 6, leaving 2, and then we multiply across. 2 times 2 is 4, 3 times 1 is 3, so we get 4/3 for that. Now, that is basically what we're going to be doing. One other thing maybe I should mention is if you have a fraction like 8 over 36 and you want to reduce this fraction, again, what you are canceling is factors that are common to both terms. 8 you could think of as 4 times 2, 36 you could think of as 4 times 9, and with that, the factor of 4 in the numerator cancels with the 4 in the denominator. So anytime there's a factor of the problem in the numerator that's the same as a factor of the problem in the denominator, you can cancel it. You will be in trouble if you cancel things that aren't factors. In polynomials, which is where we're going with this, if you have two terms like 4x plus 7, 4 is not a factor of the polynomial, it's just a factor of one of the terms. So when you're canceling a factor, or when you're canceling, make sure that it's factors you're canceling. If you cancel anything else, you have just ventured into the realm of the wrong answer. Now, to continue, sometimes when you have an algebraic rational expression, and an algebraic rational expression is something where you have a polynomial in the numerator and a polynomial in the denominator. And let me give you an example here. Let's imagine we have the rational expression x squared plus 2x minus 8 over x squared plus 7x plus 12. Now, if we were to put negative 4, if x equals negative 4, then on the top we would get negative 4 squared plus 2 times negative 4 minus 8. Well, now negative 4 squared is 16. 2 times negative 4 is negative 8. Minus 8, 16 minus 8 minus 8 is 0. And on the bottom, if we have negative 4, we have negative 4 squared again, plus 7 times negative 4, plus 12. Now, negative 4 squared again is 16. 7 times negative 4 is negative 28, plus 12. Now, 16 plus 12 is 28 minus 28 is 0. So we get 0 over 0. And so this expression right here, x squared plus 2x minus 8 over x squared plus 7x plus 12, does not give us an answer when x is negative 4. We call this 0 over 0 an indeterminate. Let me do that better. An indeterminate form. I-N-D-E-T-E-R-M-I-N-A-N-T. Indeterminate form. There we go. Now, if you look at this algebraic rational expression, it actually factors in the numerator into x plus 4 times x minus 2, and the denominator factors into x plus 4 times x plus 3. Now, notice that x plus 4 is a factor of the numerator, and x plus 4 is a factor of the denominator. Because of that, our rules say that we can cancel those common factors out. The only problem is that when you do that, you get x minus 2 over x plus 3. And when you put negative 4 in, you get negative 6 in the numerator, you get negative 1 in the denominator, so negative 6 over negative 1 is 6. So we get 6 rather than 0 over 0. So what has happened is we have lost the number that gives us the indeterminate form when we cancel these out. So what you really need to do is whenever you're canceling out factors that could be equal to 0, you need to restrict the domain of this new expression so that you're not allowed to put that number in, because you're not allowed to put negative 4 in the original one because you get the indeterminate form, and at the end you're not allowed to put the negative 4 in because you do get a number, and then if we were to say this is equal to this, if this is equal to this, we would not be being truthful, because at negative 4 they give you different values. So care must be taken to make sure that you exclude values from the domain that are canceled out when you cancel out factors. In other words, anything that makes a factor that you've canceled out 0 must be excluded from the domain. All right, now, the next thing that I need to talk to you about is, if you think about this, x minus 1 over x minus 1 is equal to 1, except, of course, when x is 1. But so any number over itself is 1. Now, if you have x plus 3 and 3 plus x in the denominator, it's easy to see that x plus 3 and 3 plus x are the same thing. So that is also equal to 1, except, of course, let me just put these in x not equal to 1, and here x not equal to negative 3. Okay, so these kind of expressions, anything over themselves, are equal to 1. Now, one of the things that comes up, and they love to do this to you in the math book, is something like x minus 2 over 2 minus x. Now, you see, x minus 2 is not the same thing as 2 minus x. In fact, if you were to take a look at this, for any number you put in for x, the numerator and the denominator will differ by a negative sign. Put in 5 for x, for example, in the numerator 5 minus 2 is 3, the denominator 2 minus 5 is negative 3. Put in 17, 17 minus 2 is 15, 2 minus 17 is negative 15, 15 over negative 15, again, negative 1. So when you have a binomial that is commuted around a negative sign, when you cancel those factors out, the residue is negative 1, not 1. So if you're reducing a fraction and you have something like 7 minus x in the numerator and x minus 7 in the denominator, something like that, you can cancel this out, but you have to realize that you get a -1, not a +1. And of course, for example, x can still not be equal to the value that makes what you've canceled equal to 0. So be on the lookout for that. Now, when you're simplifying rational expressions, sometimes we have big, long monomials to take care of. And let me give you an example of one of those. Let's say, for example, we say 45 a squared b cubed c over 36 a to the 4th b squared c cubed. Now, this is different from some of the expressions I showed you earlier because everything in the numerator is being multiplied together. Everything in the denominator is being multiplied together. 9 is a factor of the numerator because it's a factor of 45. 9 is a factor of the denominator because it's a factor of 36. A squared is a factor of the denominator, and a squared is a factor of the numerator. There are no plus or minus signs in the numerator or denominator, so this is a monomial over a monomial, and the factors are pretty obvious. So you can just go across and get rid of common factors. 45 has a factor of 9, leaving 5. 36 has a factor of 9, leaving 4. A squared is a factor of both, leaving an a squared in the denominator. B squared is a factor of both, leaving a b in the numerator, and c is a factor of both, leaving a c squared in the denominator. So we end up with 5b over 4a squared c squared. All right, so now when you're dealing with monomials, it's pretty much that easy. Now, if you're multiplying and the rational expressions just contain monomials, you can do pretty much the same thing, and you can cross cancel. For example, 56 x squared y over 15z cubed times 10 xz squared over 16 xy cubed. Now, any factor in the numerator that's the same as a factor in any denominator in this, because these are monomials. We're just multiplying everything across the numerator, multiplying everything across the denominator. So if we can find a factor in common in the numerator and denominator, we can cancel it out. So there is a factor of 8 in 56, leaving 7, factor of 8 in 62, leaving 2. There's a factor of 5 in 15, leaving 3, a factor of 5 in 10, leaving 2. There's a factor of x here, and a factor of x here, leaving an x. There's a factor of z squared here, and there's a factor of z squared here, leaving a z. There's a factor of y here, and a factor of y here, leaving a y squared. And oh, right above, we have a factor of 2 up here and a factor of 2 down there, and they cancel. So now, with everything that we have left, we have 7x times x. Don't lose those factors. 7x times x, or 7x squared in the numerator, and 3zy squared in the denominator. And that's cross-canceling and reducing all in one. So that's how you do those monomial terms. Now, if we're multiplying rational expressions and we have polynomials, it gets a little bit more complicated. Now let's take a look at an example. If we have x squared plus x minus 6 over x squared minus 4, and we're multiplying that by x squared plus 7x plus 10 over x squared plus 10x plus 21. Now, we would love to be able to cross cancel, but the factors are not apparent at this particular point. We would first have to factor these numerators and these denominators, and that's exactly what we're going to do. Now, guys, you can't just cancel the x squareds, for example, because x squared is not a factor of any of these numerators or denominators. You have to factor the numerators, you have to factor the denominators, and then cancel the common factors. Okay, so first of all, x squared plus x minus 6. If we factor that, I think you'll notice that it's going to have to be product of two binomials. We know we have x in the first spot in each one. And then we're looking for a pair of numbers that multiply to give -6 and add to give +1. Now that's +3 and -2. Now guys, once you've factored a numerator, go ahead and cross through it because the factors are kind of taking its place. Now x squared minus 4, that's the difference of squares. So that gives us x plus 2 and x minus 2. That takes care of that one. Now x squared plus 7x plus 10 factors into x here. And we're looking for two numbers that multiply to give 10, add to give 7. That's plus 2 and plus 5. That takes care of that one. And then finally, we're looking for a pair of numbers that add to give 21, multiply to give 21 and add to give 10. That's plus 7 and plus 3. That takes care of that one. Now, I like to refer to this as playing Zorro. We're ready to cancel factors that are alike. Here's an x plus 3. Here's an x plus 3. Here's an x plus 2. Here's an x plus 2. Now, here's an x minus 2. Here's an x minus 2. Yes, I know they're right above each other, but that's reducing the fraction. Okay, and that looks like pretty much it. So now we're going to say this is equal to x plus 5 over x plus 7. But we have to make sure that we exclude from the domain the numbers that would make the things that we canceled equal to 0. We canceled an x plus 2, so x cannot be equal to -2. We canceled an x plus 3, so x cannot be equal to -3. And we canceled an x minus 2, so x cannot be equal to 2. So the answer to this one would be x plus 5 over x plus 7, and x is not equal to -2, -3, or 2. Now, if we're dividing rational expressions, then it's important for us to change that to a multiplication problem and then do just what we did in the last one. So let's imagine we have x cubed minus 8 over x squared minus 4, and we're dividing by x squared plus 2x plus 4 over x plus 2. Now we'll rewrite that question as x cubed minus 8 over x squared minus 4 times x plus 2 over x squared plus 2x plus 4. Now, I purposefully created this problem because this first binomial here, x cubed minus 8, can be factored, and it's the pattern that I told you back when we were talking about factoring that you're going to have to memorize, because there isn't any other way to get this. X cubed minus 8, let's just kind of write this over on the side, x cubed minus 8. Now notice the way I wrote 8. 8 is 2 cubed. So what I have is the difference of cubes. Now there's a pattern for that, and if you don't remember the pattern, you're going to have to go back and look it up. But it turns out that this factors into x minus 2 times x squared plus 2x plus 4. So that's what we're going to put over here in place of the x cubed minus 8. So I'll just cross through that. There we go. Get rid of this one for a minute. Oh, they're both there. All right, fine. Now, x squared minus 4 is the difference of squares. It factors into x plus 2 times x minus 2. Now, x plus 2, that's a monomial term. We're already done there. And x squared plus 2x plus 4. Now, that doesn't factor. There's no numbers that multiply to give 4 and add to give 2, so we can't factor it anymore. So it looks like we're ready to play Zorro, but here's really a cool thing. X squared plus 2x plus 4 is a factor of the denominator, the whole thing, and it's also a factor of the numerator. Now x minus 2 is a factor of the numerator and a factor of the denominator, and then x plus 2, whoa, is a factor of the denominator and of the numerator. So we end up with, we end up with 1. Of course, x is not equal to 2 or -2. Now, this does not have a 0. It doesn't factor, so there aren't any zeros to that one. So all we need to do is we need to say, oops, that x, the problem is equal to 1, and x is not equal to 2 or -2. All right. Now, it is important on these rational expressions when you're multiplying and dividing that you factor them. Now, I would like to talk to you also about complex fractions because that's a part of this particular section. If you have something like y minus x over 9 over x squared minus y squared over 18, this really becomes y minus x over 9 divided by x squared minus y squared over 18, that's what I said, times 18 over x squared minus y squared. Notice what I've done is I've flipped this denominator and I'm multiplying it by the other, okay? Now, there's only one polynomial that factors here, and that's the x squared minus y squared. It becomes x plus y and x minus y. And let's see if we can play Zorro here a little bit. Well, first of all, there is a 9 that's a factor of 9, leaving 1, 9 factor of 18, leaving 2. And the thing that I mentioned earlier, I have a y minus x in the numerator, I have an x minus y in the denominator. Now that's the same binomial, but it's commuted around a negative sign. So I can cancel that, but when I do, the residue is -1. Now I'll choose to put the -1 up there. And so that gives me -1 times 2, or -2 on the top, and x plus y times 1, or x plus y on the bottom. And of course, x is not equal to y, because if x minus y equals 0, that add y to both sides, we get x, or x minus y is not equal to 0, add y to both sides, we get x is not equal to y. So we have to exclude x and y being equal from each other to get -2 over x plus y. I'd like to show you one more example of complex fractions, and this one is a little bit more complicated, but we'll take a look at this and hopefully you'll learn some things from this. 1 plus 4 over x minus 1 over x plus 1 minus 8 over x minus 1. Now, if I want to simplify this fraction, notice what I've got now is I've got a numerator that has a fraction in it, and I have a denominator that has a fraction in it. Now, one of the things that is true, and I'm going to say this twice, I'll say it slowly, then I'll say it again, and if you don't quite get it at first, maybe you want to pause here and go back and listen to it a couple more times and think about it. When you multiply a fraction by a multiple of its denominator, your answer won't be a fraction. Let me say that again. When you multiply a fraction by a multiple of its denominator, your answer won't be a fraction. Let me illustrate that. If you take 1/3 and multiply by 3, you get 1. 1/3 times 9. Now 9 is a multiple of 3, gives you 3. 1/3 times 729 gives you 243. See, 729 is a factor of 3, and so when you multiply 1/3 times 729, you get an answer that is not a fraction. Now, we're going to make use of that fact here by saying the denominator, the x minus 1 is a denominator in the numerator, and it's a denominator in the denominator. So what I'd like to do is I would like to multiply the numerator of this fraction by x minus 1. Now, ordinarily that wouldn't be allowed, because if I just multiply by anything I want, it'll change the value. And usually when you have an expression and you're trying to simplify it, if you get a different value, we call that the wrong answer. So the only thing I really can multiply by is 1. But if I put x minus 1 over x minus 1, that is 1, and I can multiply this fraction by that. Oh, let me just mention this too. Before you start, see, notice here we're subtracting this fraction 8 over x minus 1. Now, that is a mistake just waiting to nab you. So what I recommend that you do whenever you have a minus sign out in front of a fraction, make it a plus and apply that negative sign to the numerator. Don't apply it to both the numerator and denominator. That would be very bad. Okay, so now what I have is I have 1 plus 4 over x minus 1 over x plus 1 plus -8 over x minus 1. Now what I'm going to do is I'm going to multiply the numerator and denominator of this fraction by x minus 1 over x minus 1 over 1. Now, we've got lots of stuff to do here. This fraction here is being multiplied by this binomial, so we have to distribute. Now, 1 times x minus 1 over x minus 1 is x minus 1. Let's see, x minus 1 over 1 times 4 over x minus 1. Notice here the x minus 1s will cross cancel, leaving plus 4. Now in the denominator, I have a trinomial, so this has to be distributed over all three of these terms. So first of all, x times x minus 1 over 1 gives me x squared minus x over 1. Now x minus 1 over 1 times 1 gives me plus x minus 1. And then x minus 1 over 1 times negative 8 over x minus 1. Again here, you should be able to see that the x minus 1s will cross cancel here on this part. So, oops, that's not what I want. I want, no. Yeah, I want that part out. There we go. So the x minus 1s will cancel, and we're left with minus 8. Now let's do what we can. We have x plus 3 over x squared minus 9. Now we're not finished because x squared minus 9 factors into x plus 3, x minus 3, and we can cancel out the x plus 3, leaving a 1 up here. So we get 1 over x minus 3 for our final answer. Now, x cannot be equal to negative 3 because x plus 3 is 0 when x is negative 3. Now, guys, it also can't be equal to 1 because up here at the beginning, we canceled an x minus 1 over x minus 1 out. So our answer is 1 over x minus 3. X is not equal to negative 3 and to 1. Now, that's pretty much a rendition of the kind of things that you're going to be doing in this particular section. You do need to do this assignment. You do need to do it carefully because it can be complicated. And if you had trouble with the x cubed minus 8, if you didn't know how to factor that, then go back and review that factoring pattern. That is very important. And we're done.